Today we're going to talk about interest. Albert Einstein is reported to have once said, "The most powerful force in the universe is compound interest." Whether Einstein actually said this or not, it's a great financial principle to live by. Without attention, compound interest can rapidly become a force of ill intent and create financial burdens we never planned on. Compound interest can also become the means to our financial dreams through a prudent investment. So if you're investing and you're trying to gain money, compound interest is a great thing. While if you're taking out a loan and trying to borrow money, it's a horrible thing. Interest is the amount charged by a lender for borrowing money. The principal is the sum of money on which interest is charged, your initial amount, essentially. And the interest rate is the amount charged to the borrower, expressed as a percentage of the principal. The annual percentage rate is the yearly interest rate that is charged for borrowing. APR is normally given as a percentage per year. And a simple interest formula is I equals PRT, where we multiply the principal times the rate times the time. Determine the interest that is accrued on $5,500 for 5 years as a rate of 8.5%. So if we use I equals PRT, then the principal is $5,500. The rate is 8.5%, or as a decimal, 0.085. And for 5 years is the time. Multiply these, and we get that the interest is $2,337.50. That's how much interest is gained. Now, if we were trying to find after 5 years what's the total amount owed, then we would add that interest that was accrued back to the $5,500. Ian is purchasing a new television with a deal from Big Screens or Us. Okay. The deal offers 90 days same as cash to make the purchase. This means that at the end of 90 days, if Ian has paid off the cost of the television, he owes no interest. However, if Ian does not pay off the amount, he owes simple interest for the original purchase amount calculated over the entire 90 days. So the interest is going to start accruing from the day he buys it. And if he gets it paid off, he's got no interest. But Big Screens or Us is banking on him not paying it off. And if he doesn't pay it off, then he owes interest for those 90 days regardless, plus any interest that he accrues moving forward. If the price of the television is $2,650 with tax included, with an annual interest rate of 21.99%, yes, that's totally normal, how much would Ian owe on the 91st day if he's made no payments during those first 90 days? Okay, so we're going to use I equals PRT again. The principal is $2,650. The rate, changed to a decimal, is 0.2199. We need to think for a minute about what time would be, though, because we need time to be in years. So 90 days is equal to 3 months, right? And so what part of a year is that? Well, that's 3/12 of a year, or 1/4 of a year. So 1/4 is going to go in for time. That's $145.68. So he's going to owe that much interest if he doesn't pay it off in 90 days. So be careful about those quote deals. Compound interest is interest that is computed based on both the principal and the accrued interest as an additional principal at each interval. So, for example, if you've got a loan and you have an amount that you owe interest for the first month, okay, and you don't pay anything on it, then you're going to have the interest for the second month is going to be on the principal plus the interest for the first month. The interest for the third month would be on the principal plus the interest for the first and second, all added together, okay? That's compound. It's compounding over time. The future value is the total amount of money, A, that has been accrued after compounding at an annual percentage rate, R, based on the initial principal, B, within compounding intervals for T years. And in compounding intervals, that means how many times per year is it compounded. So if it's compounded monthly, that would be 12 times per year. Quarterly would be 4 times a year. Semi-annually would be twice. Annually would be once. Daily would be 365. That covers most of what you'll see. Future value of a compound interest account is calculated then with this formula. A equals the principal times 1 plus the rate divided by N to the power of the N times time. And here's your different compounding periods. So example 3 says Lily deposits $12,000 into an account with an annual interest rate of 4.5% compounded monthly. So this is a savings account. If she leaves the money in the account for 10 years, what will the future value be at the end of this time period? So we're going to use our formula. The principal, the initial amount was $12,000. The rate, 4.5%, change it to a decimal, 0.045. It's compounded monthly, so N is 12. And that's to the 12 times T, T is 10. We can simplify this a little bit. If you take 0.045 and divide by 12, you get 0.003. Add that to 1 and you have 1.003. And 12 times 10 is 120. So there's 2 ways you can do this. If you have a calculator, you would just put this in, or if you have a graphing calculator, you would put this in as 12,000 times 1.003 to the 120. And you would get your answer of approximately $18,803.91. That's how much she'll have in the account after 10 years. Not bad, if she's patient. The other way that you would do this, if you don't have a graphing calculator, you could put it in Excel. That would be nice and convenient. You'd use the same formula here with the equals in front. Or if you're using just a phone calculator or a scientific, you would need to go by order of operations. So the first thing you would do is 1.003 to the 120, because exponent comes before multiplication, and then you would take that answer and multiply by 12,000. Okay? The continuous compound interest formula is A equals P times E to the RT. And E is just a number, okay? It's a number like pi. It's in your calculator. You'll use it. You'll be good to go, okay? So find the future interest of $8,900 invested at a rate of 2.05%, compounded continuously over 15 years. So the principal amount is $8,900 times E to the rate, which is 0.0205, because we had to change it to a decimal, and T is 15 years. You can simplify this a little bit before you put it in your calculator if you like. The exponent would be 0.03075. And then if you've got a graphing calculator, you can just put in 8,900 times E. Look for the E button on your calculator. It's above the LN. Do second LN. And then 0.3075. It'll go ahead and put the little up hat in there. If you don't, then search for the E button on your scientific calculator or your phone. It varies where it is, so I can't tell you exactly. But you'll do that first and then multiply by 8,900. So we get about $12,104.19 in this account after 15 years. Example 5 says, assume you wish to deposit $2,500 into an account bearing 6% interest over 10 years. What is the maximum future value possible after 10 years? Well, the maximum future value would be the more times, let's write this down, the more times compounded the greater the value. So if you're investing, you want to compound a bunch. If you're taking out a loan, you want to compound as little as possible. So the greatest amount, since this is a savings account, would be continuously. So we'll use A equals PE to the RT. 2,500 times E to the 0.06 times 10 would be $4,555.30. Part B asks, what is the maximum amount of interest possible after 10 years? Well, we've already found the maximum accumulated amount is this right here. So, if we want to find the interest, we're just going to take that future value that we found, or A, which is this number here, and subtract off the principal. So basically A minus P. So the interest that was accumulated over those 10 years is $2,055.30. The annual percentage yield is the effective annual interest rate earned in a given year that accounts for the effects of compounding. So APY is calculated with this formula. Now what this is, again, is Sorry, I was just looking out the window. My cat was chasing a bird, and it got away. Anyway, kind of funny. So I got distracted. Okay, sorry. Back to this. So APY is if you figured out how much interest has been calculated by compounding for a year, then it's the amount, it's the rate over that was accumulated over that whole year. Okay? And so the formula is 1 plus the rate over n to the nth power minus 1 times 100%. So let's look at an example. And in case you didn't understand what I was saying there, hopefully working an example will help you understand. Samantha deposits $5,000 in an account paying 5% interest per year. Find the APY for Samantha's investment if the interest is compounded monthly. So, we're going to use our formula. 1 plus R over N to the N minus 1 times 100%. And we don't have a T in here because we're just looking for it over the year. So we plug in 1 plus our rate of 5%, 0.05, divided by N. It's compounded monthly, so N is 12 to the 12th power, minus 1 times 100%. Okay, so if we put this in our calculator, we've got 0.05 divided by 12. And that's a big, long decimal that keeps on going. So if you're using a graphing calculator, let me show you first how to put this into a graphing calculator. If not, and you could also put it in, like I'm getting ready to show you, into Excel and kind of save it as a formula and plug things in. So I'll show you an example of that in a bit. But I'll probably add it on to the end of this video. But in a graphing calculator, you could say parentheses, parentheses, 1 plus, then you've got division, so you need parentheses again. So 0.05 divided by 12, close, to the 12, minus 1, close. So we've closed here, and so I'm missing one. I think, yep. So 1 plus, gotcha, need to close this parenthesis. Okay, to the 12, minus 1, close again, times 100%. So just times 100. And you should get, where did I write it down? 5.116%. So let me explain a little bit about what this answer is, and then we'll talk about how we would do this without a graphing calculator or Excel. So she's paying 5% interest per year, but it's not simple interest. It's not straight 5%. It's being compounded each month. And so APY is the amount that the percent over the entire year with the compounding that was done. So that's what we found here, 5.116. Okay? Now, if you don't have a graphing calculator, there's going to be a few more steps to this. So here we go. If you'll take 0.05 divided by 12, you get 0.00416666667. Add that to 1. We want to put as many decimal places as our calculator gives us in order to avoid rounding error. Because if you're off by 1/100th of a number on your homework in the computer, it's not going to count it right. So many decimal places as possible. So I'm going to write down every single one of these that I've got. Okay, and then we'll take that number and raise to the 12th power. So we'll have 1.0511611898 minus 1. So subtract 1, multiply by 100, and we get our same number, 5.116%. Okay? And at the end of this, I'll include a little example of how to put this in your calculator, or in Excel, excuse me. So part B says finds the APY if interest is compounded daily on the investment. So we're going to do the same thing, only with N as 365. So 1 plus 0.05 divided by 365 to the 365 minus 1 times 100%. Now, something that's important here, if you're using the calculators, is you're going to want to, as I'm working these problems, stop the video for a second, put it in your calculator, make sure you're getting the right number. If you're not, then you're not following order of operations or using parentheses somewhere or something like that. If you're not able to get the right number, the number that I'm getting in the example, please be sure and email me so that I can try to help you get there, okay? Because that's very important. So stop the video, see what you get, and see if it's the same thing that I get, okay? If we take 0.05, divide by 365, and add 1, and raise to the 365th power, and subtract 1, we get 0.05127. So that comes to 5.127%. Okay? So again, make sure that you get that number and whatever apparatus you're using. And if you can't figure out what you've done wrong, shoot me an email. Example 7 says, suppose that the APD Bank of the South advertises the following rates for their personal loans. So if it's less than $20,000, the rate is 10.49%. Between $20,000 and $99,999, it's 9.99. You can read the table. Find the APY, or effective interest rates, for each of the loan categories. So, for the first one, this is just what we've already done. So I'm going to go through this fairly quickly, okay? We just did this in the previous example. So we've got 1 plus, the interest rate for the first category is 10.49%. So 0.1049. It says, compounded quarterly. So N is 4 times 100. And you should get 10.91%. For the second one, the The interest rate was 9.99. So 0.0999 divided by 4 to the 4 minus 1. I neglected to write down that minus 1 up here. The answer is correct, but I forgot to write down the minus 1. So there we go. Times 100%. So the APY would be 10.37%. And I think I've got a spot to write these down over here. And then the last one, do the same thing except for plug in 0.075 for the rate. And it is 7.714%. Assume you wish to borrow $300 for 2 weeks in the form of a payday loan, and the amount of interest you must pay is $25 per $100 borrowed. This means that at the end of 2 weeks, you owe $375. What is the APR? Well, here is how you calculate APR in a situation like this. You would take the short-term interest rate and multiply by however many weeks, 52 weeks in a year, divided by the length of the loan. Okay? So your short-term interest rate was 25%. How do I know that? On every $100 borrowed, you're paying $25. So 25% of $100 is 25. So 25% times 52 weeks. And we are borrowing for 2 weeks. So that would be 0.25 times 52 divided by 2, 650%. Wow. What is this saying here? You know, payday loans are something that you can get if you're short of money before you get paid. And the interest rate on them is obviously, as you can see, astronomical. You're going to pay it back soon, so you're not going to end up paying this whole 650%, but still, it is outrageous. And sometimes, or in some states, it's actually illegal to give out these type of loans. Okay, so that concludes our lesson, except I'm going to add a couple of Excel examples on here. Okay? A few of these with Excel. So for example 3, it said that Lily deposited $12,000 into an account with an annual interest rate of 4.5% compounded monthly. If she leaves in the money for 10 years, what will the future value be at the end of this time period? So the first thing we need to do is put in our information. So the principal, let me make this bigger, was $12,000. The rate, we'll make this, there we go, it looks a little bit better. The rate is 4.5%. Now you can change that to a decimal, or you can just put in 4.5 with 1% like that. And Excel knows what to do with that percent. So it knows to, in the background, change that to a decimal. Then we need N. It says it's compounded monthly, so we'll say 12. And T is 10 years. Okay, so here's how our formula is going to work. We've got to be very careful with our parentheses and everything here. So we start with equals P, which is located right there. So B1 is P. Then we've got a parenthesis, 1 plus. Then the rate divided by N, that needs to be in parentheses too. So parenthesis, and it color codes your parentheses so you know where to close them. We've got our rate was B2 divided by B3. That's our N. Close parenthesis. You can see how it's color coded there. And then we need to close that first parenthesis. That was black. And then we need to raise to NT. So hat button, it's above the 6, so shift 6. And NT, N times T needs to be in parentheses also. So parentheses, N, we'll select on B3 again, times, that's shift 8, and then T, close that parenthesis. And this should give us the same, oops, I've done something wrong. Let's see if I can figure out what this is. I think I need to put a times in there. There we go. Got it. Okay, so you see what I did? You can always look at your formula up here. It doesn't know to automatically times when you use parentheses, like with the calculator. So I had to stick an asterisk in, and you can always double click on it to see what it looked like too. But we did get the same number as in our example before. Example 7 also. Suppose that the APB Bank of the South advertises the following rates for their personal loans. Find the APY, or effective interest rates, for each loan. Okay, so we've got our different APRs, and N is 4 because it said it was compounded quarterly. And then the rate's going to vary. We've got them listed over here. So we really don't need that R. Okay. So we got to be very, very careful how we put this in. And so we've got parenthesis, parenthesis, 1 plus the rate, parenthesis, the rate divided by N. So there's our rate. Remember, it knows what to do with the percent. Divided by N, that was 4. Then close. And we've closed the parenthesis around R over N. Now we need to close the parenthesis around 1 plus R over N before we raise to the nth power, 4. Then minus 1. Close that very first parenthesis and times by 100. And cross our fingers. There we go. We got it. Okay? And you could do that for each one, but I believe, let's see. Yep, if we just, let me show you what I did there. If we just drag down, it'll factor each of the ones below for you. So all I did was grab this corner here and pull down like that. And then you've got them all.